All right, we're back. Any of you need a little bit more time, or are we ready to start? Okay. Okay, perfect. So we are going to start, but if you want more time, just write down the chat. We can stop. Okay, first type of exercise that you are going to see on Alex. In this exercise, you want to write the exponential function. Okay, or the exponential function rule is at the end, it will be just the equation. Okay, we know from the parent function, the parent function is f of x equal c, where c is just a factor that could be any real number, times, and I'm going to use the parentheses because I want to make explicit. I don't want to get confused with c and a. A, which is the base, the input goes to the exponent on top of a. So an a is going to be positive, not equal to 0. Not equal to 1, sorry. And not equal to 0 as well, yeah. But it will be positive from 0 to 1. We are going to have a decreasing behavior, and from 1 to positive infinity is going to be a increasing and decreasing behavior from 0 to 1. All right. So our goal is to find the value for C and the value for A in this exercise. Once we find those values, we have finished with the exercise because we are going to have the complete equation. All right. So remember about the initial value. So we have a table of value here, x and y. So x is the input, y is going to be the output. So y is also f of x. So from these values, we need to use these values to create or to write the equation of the function. So step number 1, what you are going to do, and remember the initial value. So here's the initial value. The x value is equal to 0, and you will see that now that if we use the initial value, things get very easy here, because it means that f of x, f of 0, we know that is equal to 10. Okay, so I'm not going to put 10 just yet. I'm just going to use the value of x in the parent function. Okay, and by the law of exponent, we know that a raised to the power of 0 is just 1. Okay, so c times 1 is just c, and we know that the value of the function, the initial value of the function is 10. And since we use x equal to 0, it means that c is equal to 10. So from step number 1, we got the following. We got that f of x is equal to 10 times a raised to the power of x. Any question on this step? Okay, so now on the second step, the goal is to find the value of a. So what I'm going to do here, since we have used 0, I'm going to use the next easier x value, which is 1. So using x equal to 1, we know that the function or the y value needs to be equal to 50. Okay, so from that point, so I'm using now this one. From that information, now we can find the value of a, because f of 1, I'm not going to put 50 just yet, I'm just going to follow what we have here. 10, open parentheses, because I want to make the distinction between the value of c and the base. So a raised to the power of 1. Okay, but a raised to the power of 1 is just a. All right. So we have here 10 times a, and we know that is going to be equal to 50. So now we have an equation of 10 times a equal to 50. We divide both sides by 10, and we got a equals to 5. Okay? So now we have the complete function. Okay? And that is the result. All right. So see, it's not too complicated. Once we know how to follow the steps, the initial value is key here. We want always to use the key value as the starting point. So that's the step number 1. Any question?
How did you know to, like, after you got 10a and then you got equals 50, how did you know to divide all of that by 10? Just because you put 10a on the other side? Do you always just put that on the other side?
Yes, but let me put this in color so you can see it. So I created an equation from this step here. So when I use x equal to 1, what we got was an equation. When I substitute x with 1, so I should put that also in colors. So we know that 10 is, okay. So when I substitute in what I got from step number 1, the value of 1 into x, I got then 10 times a. From the information that the exercise gave to me, which is when x is equal 1, the y value is equal to 50. So that means that f of 1 is equal to 50. I can continue and say, well, 10 times a is going to be equal to 50, even though I do not know the value of a. From this information, I was able to create the equation this equation. 10 times a. A is a variable. Okay? If you want to solve for a, okay? Well, you want to solve for a. A is something that is unknown and it's a variable. So in this equation, you want to solve for a. How do you solve for a here? Well, 10 is being multiplied by a. I want to get rid of 10. I want to put 10 on the other side of the equation. So because 10 is being multiplied by a, I divide both sides by 10. So I can cancel this 10 here. And now 50 divided by 10 is 5. So on the left side, I just got a, and then on the right side, I got 5. Did I answer your question, Rachel? Okay, perfect. Any other questions? All right. Something that I didn't told you on the intro is I told you about the shape of the graph. I told you about the horizontal asymptote. I didn't told you about the key points. Okay, so let's do it here first. and then we go back. Well, let's do that first, and then we go back to this exercise, because we will need to know how to the key points of the parent function in order to graph this function. So let me go back to the intro, and let's talk about the key points. And the key points are very easy here with the parent function. Okay. So that's the parent function. So you want 3 key points, and you want to use -1, 0, and +1. Right? Or something like that. Okay. So because x is the exponent and it is -1, what it's going to do with a is going to just put a on the denominator. So it will be c times 1 over a. Okay. A raised to the power of a raised to the power of 0 is just 1, so it will be just c. And a raised to the power of 1, it will just c times a. Okay? To make things a little bit easier, this is when we consider c as all real numbers. But sometimes it's going to be easier, and I believe you want to do this. Do not take into consideration c. Okay, so there are 2 options. You will select which one do you prefer. Just f of x equal a raised to the power of x. That means that the value of c is 1. When we do that, we simplify the key points. So it will be 1 over a, 1, and a. Okay, so that you will see that when it's negative, we use the reciprocal of the base. When it's 0, it's 1, and when it's 1, we just use the base for the y value. Okay, so I'm gonna use this one rather than having c representing all the real numbers. Okay, for me it's easier to work with f of x equal a to the reciprocal of x. Okay, so those are the key points, so 3 key points from the parent function. So I have them here. All right. So we need to, I don't know how well can you see. Maybe I'm going to write the function below. The function that we have is the following, and we need to write this. We need to graph this function. Can you tell me what is the base of this exponential function? It is an exponential function because x, which is the input of the function, is on the exponent, right? That makes this an exponential function. Okay. My computer is dying. You will see. I hope it lasts until the last of the semester. All right. But let's go back here. What is the base of this exponential function? The base value. So that means the question is, what is the value of a in this situation? It is e. Okay. So the base here is the value of e. E is a representation of the rational number 2.718. I don't know. let me see. E, where are you? That is an irrational number. Remember, irrational numbers do not end, do not finish, or do not have an endpoint in the decimal representation. So that is why the letter E is used. Okay, because this is a irrational number. When we are working with irrational number here, you can go to your calculator and enter -1 and get a y value, 0 and get a y value, and 1 and get a y value. That's okay. But when you are working with a irrational number, those y values are going to be weird. So it's going to be difficult to plot the points on the coordinate plane. So you want to use what you know about transformational functions. That will help you to understand better where the key points of g of x are located. So that's the base. So that means that the parent function of g of x would be e raised to the value of x. And we know then from the study of the exponential function now that the key points of f of x here are going to be 1 over e, 1, and e. Okay, so those are the key points. Let me put them in coordinate representation. So -1, 1 over e, 0, 1, and 1, and e. Okay, but that's the parent function. Now we want g of x. Can you help me identify the transformations? So let me focus here. Can you identify the transformations? I know I agree with the number 1 there, but down, I don't think it would be down. Okay, Amanda, you can simplify what you said as vertical compression by 1/3. We are multiplying the base, the C value here is 1/3, right? So there is a vertical compression by 1/3. Okay, I need 2 more. There are 3 transformations here. Yes, left by 4. We have an addition in the input group. The input group here is the exponent because there is where the input is. Going left unit to going to the left 4 units. Yes. And the other one is Rachel just said down, but it's up because we have +1. Okay, we have +1. From the parent function here, I forgot to put the horizontal asymptote. The horizontal asymptote here is equal to y equal to 0. Okay, so we have 3 transformations. We have 1 vertical compression by 1/3. We have up 1 unit, and we have left to the left 4 units. Okay, so the first 2 are vertical. So we need an equation for y, and the other one is, the third one is horizontal. So we need an equation for x. Okay. So can you help me to combine these two first transformations, these two vertical transformations, into an equation for the y values? Times 1/3, okay, I agree with that. Plus 1, perfect. This is the equation for the y values. For an equation for the x values. -4. All right. So then we need to apply those equations to the prime function, the key points. All right. So g of x, and then I should copy this. I'm going to put the horizontal asymptote here below. Remember, y equal to 0 is the horizontal asymptote. So we are going to do this now for and I will use colors because I don't know why I'm not using more colors today. Field, right? All right. So those are the equations. Copy. Paste here. Yeah, it is. Okay. Can you give me the new points? This point are going to be weird because we have a base that is an irrational number, e. Let's start with the x values. Can you give me the x values? -5 and -4, -3, correct? Now the weird ones, the y values. Let's see how you wrote those. Right, so Rachel, I have the first one, 1/3 times 1/e plus 1. We can simplify that as 1/3 times e plus 1. Okay. What is the y value when x is equal to -4? So you take 1 and you multiply it by 1/3, and then you add it by 1. So it is 1/3 times 1 plus 1. But this is something that we can simplify. 4/3. When the value is -3, when the x value is -3. Okay, let's see. So we take e, we multiply it by -3, by 1/3, sorry. So 1/3 times e plus 1. And this is the result. Okay, again, these two are irrationals. This one is irrational and this one is irrational. So they are difficult number to put on paper, and the calculator, the decimals representation one end. So we want to leave them as they are right here. Okay, I'm going to show you how you will do this on Alex. Okay, there's one more thing. What happened with the horizontal asymptote? What would be? Do you think that the horizontal asymptote will change or will stay the same? It changed? How it changed? Yes. If we have vertical shift, or the horizontal asymptote will follow that shift. Okay, so 0 plus 1 is just 1. Right? So any question with this one? So let's do this. Okay, so then step number 5 will be that. The graph. All right. So let me do this here. So on Alex, step number 1 will be this one, because we have a horizontal asymptote. So you will use that one and you will place it on y equal 1. That's the horizontal asymptote. Okay, then we have weird numbers, but that's okay. We are going to use this function here, this tool here in the toolbox, and we are going just to plot the points. So you are going to type 1 over 3 times e. So you just the key of e to put e there, and then outside of the fraction plus 1. All right. 4 over 3, and so you are going to start plotting those points. I do not know exactly where they lies in this coordinate plane. They are irrational numbers, so it is hard to identify them here. So I will plot a point just as a representation, but that doesn't mean that it is the exact location there. So -5 is here. So that point should be around here, I believe. very close to the horizontal asymptote, because it's 1 over 3e is a tiny jump from 1, so very close to the horizontal asymptote. 4 over 3, it will be, I don't know, around here, I think so. And then the other one, negative 3, it will be something, I don't know, I just guessing. Maybe here. Wait, but this one is negative. Negative 3, negative 3, negative. Let me verify that these numbers are correct. E. Okay, E divided by 3. 1. Let me double check these numbers just to make sure that they are correct. Okay, I made something wrong here. I don't know why I put that negative here. That negative doesn't belong there. Okay, so now it is 1/3 times E plus 1. Okay, so I made a mistake here. I added a negative here. Previously, I got a negative here, but that's incorrect. There should be no negative here. I don't know why I put that there. Okay, now it will make more sense. It will be around here. Okay, again, my bad, I make a mistake. I added a negative where it doesn't belong. Here, at the third point, the y value of the third point, it should be positive 1/3 times E plus 1. Okay? All right, so E, what we know, E is greater than 1. E is in the base of the exponential function. So the shape of the function, it is an increasing one. So this is the shape here. Okay. So following these 3 points, I should guess that the graph should be something like this. Okay. But what you are going to do is to use Alex, and you are going to plot those points. After you plot those points, you are going to use the function here on the top, and just connect those 3 points, and that will be your answer. I think we can see it on decimals. That was 1/3 times e raised to the x plus 4. Oops. Plus 4. Come on. Plus. Seriously? Okay. Plus. Okay. Plus 4. And 1. Okay. So this is the graph. We are seeing it from decimals. Okay. And the point that we got were -5, I believe. So -5, -5, -4, and -3 around here. Okay. So that's the graph. And the horizontal asymptote, we can see it as y equals 5. Y equals 1. If I can put y equals 1. There is the blue one is the horizontal asymptote. I think if you put just Alex will take it as the value of E. Just the letter E as I did here. So that's how you did to that one. So you have seen the written work. This is the written work of this type of exercise. Okay. You need to give me again the written word, the graphs. You can get the graph, the correct graph, from your graphing calculator. But remember, you should just put the graph without the written word. You won't receive the credit for your work. I forgot to tell you, but this is the written word for this type of exercise. Okay. Initial value, then a second value to get the complete equation. And the written word, you can see it here. Those are the steps. Any question? All right. Okay, so now this last two exercises is where we are going to be solving the equations that have the exponential operator. Before going through the exercise, an important property. This is an important property that you want to know. We are going to explore this property on the next chapters. All right. On the next chapters, you are going to know why this property is true. I should just take this. So you are seeing here that we have okay, we could go to either way. So if we have the x and y are the same value, then in an exponential equation where we have the same base, the value is going to be the same. Okay, so if the base of the two exponential expression is the same, so a here is equal to a, and we have two different representation for the exponents, okay, like variables, so their value is unknown, but because the base is equal, the two bases are the same, then we can conclude that the x need to be equal to y. Okay, this is a property that we're going to explore on the next chapter when we introduce logarithmic function, the inverse operation of exponential functions. Okay, but this is what we are going to use here. This is the property that we are going to use here to solve this type of exercises. Okay. So the exercise here is 64 equal 32 raised to the power of x times 1. And we need to solve for x. X is the unknown variable here. Okay, so we need to solve for x. How do we apply this property? What we want to do is find a common base. Okay, so we need to find a common base. On the right side we have an exponential an explicit exponential expression, because we are clearly seeing the x variable on the exponent of 32. We can convert 64 into an exponential expression as well. How do we do that? So 64 and 32. Let's focus on 64 and 32. Is there anything in common between those two numbers? Can you find something in common between those two numbers? Six, 8, yeah. Six, I do not know. No, not 6, 8. 8 is something in common between them. Yeah, that's correct. Can you go further? Focusing on 8, the number 8. Is there something that these two numbers share in common, other than 8 or further than 8, beyond 8? So if you go to your calculator, you go and put 2 raised to the power of 5, you are going to get 32. And then if you put 2 raised to the power of 6, you are going to get 64. Okay? So I didn't expect you to know this just on the first one. Okay? When we are looking for a common base, what we want to do is to find if there is this number are the power or of a common number. So 64 is a power of 2. 32 this one. Sorry, my cat. 32 is also a power of 2. So 64 and 32 share that they are powers of 2. Okay, so so how would you know this? I don't know if you know about prime factorization. Okay, but this part of finding a common base, you want to practice. You want to get used to see numbers and think of bases that represent those numbers, or you want to think of exponential representation of those numbers. For example, 16 is another power of 2, so 2 raised to the power of 4. Okay, so you want to do that exercise where you can see a number and you can think of its exponential representation. That is going to help you to find a common base. When we have found that common base, we use the exponential representation. We use the exponential representation of those numbers. So what does that mean? It means that now 64 will be 2 raised to the power of 6, and 32, and careful here, because you have an exponent there, 32 will be 2 raised to the power of 5. Any questions so far? By this point now you can use the loss of exponent, because here, remember, from the loss of exponent, see what we have now? We have inside the parentheses, we have an exponential expression, and outside the parentheses, an exponent applied to that parenthesis. So what we do here, This is same as 2 times 5, 2 raised to the power of 5 times x plus 1. Okay, and now that the bases are the same, we have the same base in an equation, we are going to use the property that I just discussed. I was using this color. No, not that one. The property that I just discussed is that I'm just going to copy and paste it. Is that if we have an equation with two exponential expression on both sides, and they share the same base, then it means that the exponents are the same. So what we are doing here is that we are canceling the bases, okay? But I haven't given you an entire explanation why we can cancel the bases. Okay, so right now you are just trusting me that this is true. Okay, on the next topic you will see how we reach this conclusion. Okay, but now what we did here, the exponent was on the variable that we were solving for was on the exponent. When we use this property, now the variable is in a linear equation. And this is something that you can solve. Can you solve this for me? Can you solve this equation for me? What is the value of x here? Uh, 1 over 5. Yes, it is. So we have 5. We distribute 5. Plus 1 times 5, so it will be 5. Then we subtract 6 minus 5 is 1, divided by 5 on both sides, 1 over 5. That's the answer. Okay, that's the written word here. The written word start here. The first step, you don't need to write down your process of finding the common base. Okay, you can use your calculator. You can start like dividing by numbers, and when you find a divisor of that number, then you can go there. Okay, so this here is not part of the written word. Okay, the written words start here when you change the numbers to their exponential representations. This is also not part of the written word. Okay, that's just extra. The written word is everything here. So that's how you solve these equations. Okay, I have one more. Can you solve this one for me? Just to make sure that you are getting the process or the technique of how to solve exponential equations. Okay. When you have an answer, just post it on the chat to make sure that it is correct. Okay, I have 5 over 2. Anyone else want to share their answer? Okay. So the common base here is whenever you see 5 as the last digit on the right, you will go immediately, well, this is a power of 5. So 25 is equal 5 squared, and 125 is equal 5 cubed. So once you do that, the most difficult part here is, or the more crucial part here is that you need to apply correctly the law of exponents. So here is the beginning of the written word. So 5, then these two exponents, we multiply them together. We cancel the base, which is 5, so 2 times x minus 1 equals 3. This is a linear equation, so this should be easy for you by this point, because we have been working with this kind of function equations since the beginning. And there you have it. That's answer. All right. Okay, so all those properties that we have discussed today, I should say majority of you will end using these properties to solve equations that have exponential functions, exponential operations. Okay, today you have learned that the 4 basic mathematical operators, addition, subtraction, multiplication, division, are just other functions. You have learned the connection between function and inverse functions, and now you are learning 2 more functions: exponential, logarithmic function. We are still waiting for the units where we are going to learn for logarithmic function, but now you know that we have an exponential function that we can treat as an operator in an equation, and that it has an inverse function, which is called logarithmic function, that it is going to be studied yet. All right, so that's all I have for you today. Any questions before we conclude our class? All right. So is there no questions? Thank you for being here one more time with me. I will see you on Monday. Any question that you might have during the day, send me an email with your question. I will be happy to help you. Okay? Have a good day, Tristan. Bye.